All right, ready? So one of the first applications that we're going to focus on is the one that we tend not to like too much, right? That first application is the rate of change. Okay. So before we do rate of change, we need to understand how we can take how does this term rate of change turn into the differentiation, right? So if I give you something like this, if I give you something like rate of change of x. What does that mean? Change of x means the x, and rate means that it's changing with respect to time. Okay? So if you say rate of change of x, that's what it means. Okay? Once you see the word rate, it means dt. And this is the variable that goes on top. That's all. Okay? If you see volume changing at a rate, if you see volume changing at a rate, right? This is the term that we're using on top, and rate means with respect to time. That's okay? So those are the things that we're trying to find. All right? How do we find dv dt? Watch this here. Everybody watch here. If I ask you to find dv dt, we're going to use chain rule, right? Watch it first, so you know what's going on, right? We're going to use chain rule. If you remember your chain rule, these terms cancel out, right? So these two are the exact same thing, but these two make up this formula. So here's what I'm saying, right? dv dt is dv here and dt here. That's okay? And there's some other variable here. If it's volume, it might be radius. So dr, right? What does this say? This tells us that in order to find dv dt, we need dv dr and dr dt, right? What does dr dt say? Dr dt is the rate of change of what? Right? Rate of change of radius. Normally, they'll give us that. This one is the hard one, right? What does this shape? What does this say? Change in volume with respect to radius. How do we get that? In order to get dVdr, number one, we need an equation V in terms of R, right? So if we get something like this, V is equal to 3 pi R. Can you find dVdr from that? Yes, just differentiate. Okay? So second thing, then you differentiate. That's okay? And remember, you need a numerical answer. So after you find V in terms of R and you find dVdr, just always give it some value. Substitute for R. Okay? Everybody okay with that? So we're going to try some rate of change question. How you know the rate of change? You see in the word rate, right? Once you see the word rate in a differential question, you know it's a rate of change. Everybody okay with that? Copy it down. And we're going to try a few. These questions just got moved in, right? So go back again, I pass back. One, otherwise I'll call it. So slide over here. Lock me out. Maybe second morning. Call up by him. So I want to pull it up, right? I want to pull it up. Right. So because all the good into exam, we started hard one time. Right. I'm saying that we still waited the corner. Sorry, right. Right. But you have to right, the radius. The radius of a circular blob of ink. The radius of a circular blob of ink. Write down the question of the radius of a circular blob of ink is increasing at a constant rate. Is increasing at a rate of 0.2 centimeters per second. It's increasing at a rate of 0.2 centimeters per second. First up, find the rate at which the area, find the rate at which the area find the rate at which the area is increasing. Find the rate at which the area is increasing when the radius is 10 centimeters. When the radius is 10 centimeters. The radius of a circular blob of ink is increasing at a rate of 0.2 centimeters per second. Find the rate at which the area is increasing when its radius 10. So number one, I want you to write down the variables we're using. You see, like here we use B and R, write down what we're using there. And then write down what you're trying to find and write the formula for it. Okay? So read the question over. Nathan's, take up all the headphones, please. Troubleshoot that. Write down the variables. Write down the variables they're using. A and R, right? Right, write down what they ask you to find, write the formula for it, and then let's substitute, right? Give me a minute. Good minute. Right, so we know A is area and R is radius, right? Write down the what I want you to find. Of course, write down what they give you. Okay. Right, they said the radius increasing at a rate. So what is that? Radius increasing at a rate. What that is? The R. Go ahead. And they want you to find the area, find the rate at which the area increasing. What is that, Rihanna? Rate at which the area increasing. Huh? Yeah. How do I write rate at which the area increasing? The rate at which the area increasing. You can write dB. What does rate mean? Rate means dt, right? Rate of area increasing. So that's rate, and area is dA. Okay? Write the formula that will give you dA dt, and then see what you end up with, right? If you have minutes to get in trouble, I can do this now. So what they said rate of increase of area. So rate of increase of radius. Rate of increase of radius. Right? So in the question, you want to get dA dt, right? So what go in here? Daniel, what go in here? dA, what go in here? dt. And what's the next variable that go in here? dr, right? Right? If you look at the question told you the rate of the radius of the circular block is increasing. So the question gave you dr dt, right? And that value is 0.2 centimeters per second. That's okay? 0.2 centimeters per second. So dAdr is 0.2. Sorry about that. dr dt is 0.2. Right? Rima, how do we get dAdr? What's the first thing we need? Why would you say P? An equation of A in terms of R. What equation is that? It's a circle and its area. So A is equal to what? You have a circle, come on. Yeah, I remember that. 2 pi R. Very good. You're going to write the exam in a few days, and the area is 2 pi R. 2 pi R squared. You're getting closer. Pi R squared, right? And differentiate that from right? Differentiate A with respect to R. What do you get? 2 2R multiplied. It's a constant, it's like 3R, like constant. So you bring the 2 in front, pi, right? Pick it on your whole class. What's step 3? What is step 3? Substitute R is what? Read the question. That you do have. So why put it on the phone? What is R earlier? R is
10.
the question said radius is 10. Right? Why is it 0.2? Right? So therefore DADR. So I've got the equation. I differentiate it. I'm gonna plug in R now. So I'll get 20 pi. Right? Leave it like that. Don't go for that. Sorry. 2 by pi by 10. 20.
So
I put R in here. R is 10. Right? So I'll substitute that.
I put 10, 80, you see, I put 10, 80. Yeah, but now, without
That was right. Right? So therefore we have 20. We have 20 pi. That's the ADR put it in here now. Multiplied by 0.2. So that's 4 pi. Right? Yeah. Question. Right? It's real nice when you can write a unit. What do you think is the unit for area on time? Right? Area is in and time is in. Let's make it look real smart. Right? Don't make a note of this and somewhere in the exam that will help you. Right? Copy it down. Let's go again. Let's go again. Online. Any questions? I hope you all see how I broke it down, right? All right. I'm ready to follow what it. Mr. John. Yeah, true. Okay. Okay, now you see one again, right? Then we will talk a little bit. I'll get the formula. Let's change it, right? So look at what I did there. Because all I do is take this, put it here, box, take here, put it here, box. Right? And then the next variable goes here, wherever it is. Sometimes it's size, sometimes it's length, sometimes it's radius. See that put that in. Okay, so you're just splitting them up like that. And when you're ready,
yeah,
I'll show you the video. I'll show you the method. Are you ready? Let's go again, right? Now put it up. Like the right now. Look at it. Right? Right? You don't have to write it when you need the question, so you have to write. Put on the important things and let's go.
so don't worry, but if you come to jail, I'm going to quit and I'm at my school.
Come on, we have plan. Come on, work it out fast. Write down the variables and it starts to work it out. Right? Always define your variables. Tell them what V is, tell them what R is, right? Or whatever letter you want to use is a cube, right? So any letter you want to use beside X, S, don't matter. Online, I would like to see some answers, please. Right, especially, let me see, people looking like they don't send anything here. Mekai, Edwards. You see, man, you send me some answers. Samir, who called it Samir here? Samir in class today. Baruch. That's nice. Baruch, how long time? I don't know. Everybody done? Everybody need help? Finished? Follow these steps. You write the variables again. So you write there, start there. Write the variable, write what you have to find. Write the variable, there must be two variables there. Finished? Covered? What is supposed to do with it? What they ask to find the rate of change of surface area, right? So the volume probably helping you get something. But you follow the steps and you'll recognize you reach a point where you're going to have to use the volume to help you. Where you reach, what stage you reach? So you get one and you get two. So the problem is you now get it X or S or whatever. So you had to use volume to help you find that. What let's say you use V and what? X, right? So how are you getting X? You see the problem you end up with? You found the formula for your surface area, right? And you found the ADX. But you stick now, you can't find X. But what it give you? Volume. So how could volume help you find X? That's what you had to ask yourself. That's the question now, change your life. We could answer that. Are you done? Huh? Yeah. But if you put R equal to side, you can, right? You choose to use that. Okay, put it down, put it together, and then pass on, see what you have. Put V in for it. And yeah, right. So the variables that you should have here, you should have V for volume. You might not really need it as much. You should have X for side or S and A for surface area. Right? So we define everything. Right? What they want us to find. Finding rate of change of surface area. So they want you to find dA dt. Right? You have to write how to get that. And what they gave you there, what is 2 centimeters per second? That's dx. Dx dt is 2 centimeters per second, and the question gave you volume. Right? See how you can put everything together. I find surface area again. And have the area of all the sides, right? How many sides you have? Go ahead. Do your thing, number 2 I have. Finish already? Feel that. That's E and S. You have to be right answer, but you'll see it. I'll see the equation. I will use that. Now it's You need the part already? All right, so let's see how this one went. Right, so DA, your DA go in here, your DT go in here. Right? Look how I set up my question, right? You're not trying to get your format like this, right? Grana. Right? And here will be X and here will be X. That's okay? Right? DX, DT, we have that already, so we're good to go there. The problem is we don't have DA, DX. So how do we get DA, DX? Step number one, we need to get A in terms of X. Surface area is a cube, so I have 6 sides, where each side area is X squared. That's okay? So A is equal to 6x squared. Then we're going to differentiate that. dA dx, that's 12x. We have a slight problem. In step 3, we don't know what x is. Right? So we use this, we didn't use this. Right? We know what volume is what? Volume of a cube is x cubed. Right? So x will be the cube root of 125, which is 5. Right? So this volume helps us find x. Now that I know x is 5, I can put 5 in here. So dA dx is equal to 12 by 5. Okay? That's 6 feet. So now I know dA dx, I can come up here, and my final answer is 120 area centimeter squared per second. Right? So they get the same answer, Rihanna. You see the difference in the working, right? So in case you make a mistake somewhere, you can get a mark here, you can get a mark here. Want to do all that? Thing we can put it together. You know, see how much value. The whole thing. So they give you all this information, right? You follow this, they give you this, and you follow from B, we can find X, right? The question asks you to find dA dt. Follow together. Put the D wherever you have here, wherever you have here. And the next variable that you choose goes here. You understand that? The X dt is 2. What do we need to find? The ADX. How do we find the ADX? Equation in terms of X. That's okay? The differential of this is this. Are we done? Take X from there and plug it in. You understand that? So this is important, right? This is normally be the hardest step. Huh? Use anything, you just S if you want. For what reason? But remember, it must have a variable. So the variable, remember, is a cuboid, right? So what is the variable you're going to use to find area? Sides, right? So you could choose X. I choose X. You could choose X. Huh? Is there any volume in here? No. So you're not using volume. But the volume is there to help you find X. Okay? You okay with that? Yeah. No. That's dx dt. Read the question again. The question said the rate of change of the side, right? So that is dx dt. That is not X. Okay? Let's go again. Any questions online? Right, great job, Samir, Ahmed, Sebastian. All right, that's some bad news for you. I'll go a little bit harder. I'll go a little bit harder. Slightly harder. Can get this one. I got to read book here.
So. Then I'm not supposed to say,
Let go again. Let's go again. Next one. Take your time with this one. Right? It formatted a little bit different, but the same type of question, right? Take your time. Right? I'm gonna give you, they give you the variables already, X and Y. But just a little tricky at one step. Just a little tricky the upside down. Severe, you didn't send many answers, huh? Huh? No, he's 750. Take your time. Right? They give you what here? It's X and Y, right? Okay. See what they ask you to find. Write down the formula for what they ask you to find. Write down what they give you. See what that 3.2 represents. And then get the equation. Getting the equation and the tricky part here. Follow the give it to you there. Now I want to see how you handle it. Put together, take your time. Isa sa picture yung work na.
You went to the bathroom.
Right? Finding read. Remember, a human going to be looking at the answer, right? Set it up properly. All right, so let's see. Let's see how we came up with sample. Yeah, starting off good. Right, but now we gotta find those things, right? Right, all right here, right? We boy. What do you want?
Nah, that must be time.
Right, so let's just see what you have. Again, as you read the question, highlight the important stuff. X and Y, those are my variables. This is my equation. They gave me X increasing at a rate, so that is dx dt. Dx dt is this value. They want me to find rate of change of Y. So they want me to get dy dt. So I'm splitting it up. Dy dt. My next variable is X. So X go in here, X go in here. Everybody okay with that? Most people are sorting for that. And we know that 3.2 going right here. Right? 3.2 is what? 1.5. Nice. The big problem is to get dy dx. How do I get dy dx? I gave you 3 steps. Number 1, get the equation y in terms of x. That's okay? So you're taking this equation here and you're making y the subject. So you're going to get y is 195 on 2x. Some of you are not seeing that. Okay? You have to get an equation. How do I get dy dx? What does dy dx say? dy dx is how y changes with respect to x. So I need an equation y in terms of x. Okay? I cannot use 2xy. I need something y in terms of x and then differentiate it. Some people use quotient rule there, nothing wrong with that. Right? But I would have used 195 on 2 by x to the minus 1. I will use the shortcut method. Right? Bring up the power. Nothing wrong with quotient rule, again, the same answer. So you will end up with the differential dy dx being equal to minus 195 on 2 x to the minus 2. Okay? Going down the power minus 1 for the power. Right? So you have to know your differentiation skills, right? Whenever in doubt and you can't see that simplification, just do quotient rule. Which one? Well, I just bring down the power, which is minus 1 and minus 1 with power. So I got minus 195 on 2 minus x minus. But if you're not seeing that, just use quotient rule. Nothing wrong with using quotient rule, right? It'll take you 4 more lines, but you'll get the same answer. And then step number 3, plug in x is 15. And you'll end up with what do you get? You find an answer. Where you get from minus. What we got again? Minus 19512 by, just plug it in just like that. Plug in 19512 by 15 to the minus. You can just put it in just like that. Minus 13.2. Look, it is just like that now. I thought I don't know. What's the name? Remember, you can tell me the exact value there. That's what the dy dx. Tell me the exact value for dy dx. It don't matter. Just give me some. Negative 13 on 2. Okay, and you're done. Your question is done once you figure that out. Right? So dy dx is negative. Dy dx is negative. Dy dx is negative 13 on 30 multiplied by 3 on 2. Right? So I got minus 13 on 20. That's okay? Right? And from what I've seen, the mistake is when you all get y, you don't know how to differentiate that. Can you all see that that could be quotient rule? See that quotient rule, right? If you're not seeing the shortcut method, just use quotient rule. Okay? And plug in your 15. Belenori. Last one.
So all that time all point.
And because you're rushing it down, Kai, I like how you're talking there. You gotta help me out there. Right, Kai, guide me through this stuff. Watch how fast Kai gonna get out of this out there. What are you writing? Let's go again. One more. But if I give you back this next week, you don't even know what it's that change. Right, Kaios. 72 variables here first. Take your time and read it out. Right, it have a H, nice. It have a V. And this question was nice here. What they gave you? And they give you no, what's the equation there? And they already give you V in terms of H. Okay. So you're real good to go there. Right? This 2 is what kind?
Or rate.
What? Some of the rate of what? Letters using V and H.
E-H-O-R-T.
Nice. What are we to find?
Fine.
What weight? So let's say the weight of what?
Volume.
So how do I write that?
Or the E-P-O-R-T.
Huh? dV over. Right. Do your thing fast. Break it up for now. Tell me the formula. dV dt is what? What going here? That should be the easiest part. You just splitting them up. dV going there and what going down here? dt. And what's the next letters go in here and here? dh. See how easy earlier? And we already have dh dt. But here's the hard part. The horror. What's the hard part there? We had to get dv dh. So since you say it's the hard part, how you differentiate in that? What's the rule you using? Yes. Or anybody see a shorter way? Expand it out and then differentiate. But I will take further proof. You're okay with that? That's what we're doing in the questions, you know. You have to learn to pick these things out. Bradley, you can handle that? You sure? Oh yeah. Well, you have 1 minute. How far you can reach. Actually, we're gonna take some time for maths. You hear that? I'm gonna send a few questions on the group, try them, please. Right, I'll send about two and I'll send the answer. Okay, well, the final answer, so you can work it out.
Alright, that's all.
I'm gonna send two questions and I'm gonna send the final answer, you just plug, in fact, no, I'll send it on the LMS. Right, I'll put it on the LMS, you work it out and plug in your answer, and if you get it right, well, you'll get 1 mark. Right? Message again. Message, all right. All right. All right, so that's